All right, just finishing up another project, getting it off my hands. Chemtron Interceptor 101, 26LQ6, linear amplifier, grounded grid, nothing special. It's not a modulator amp. It's got grounded grids with no tricks, no bias, no grid leaks, no gimmicks. The grids are grounded directly and is cathode driven. Doesn't have a tuned input. And this one originally had a receive preamp, but the relay and the wiring and the preamp was all goofed up. So it's been bypassed, and also it originally had some ham band stuff in it, and that was goofy too, so all that's been bypassed. And it had a blown power transformer, and that's been replaced with the toroid. So it took quite a bit of work, and one of the reasons it was a project for so long is because I didn't want to spend a lot of time and effort and money with the transformer, and this thing probably costs half of what this thing's worth, now. And if you look from a distance, it doesn't look bad, but if you look up close, you can see some surface rust, and it's not a pretty shiny guy. Yeah, you can see it good there. It's not terrible. Cover and all that's pretty good. The inside's just pretty good. Let's take the cover off. And that's what it looks like on the inside. This one with the original tranny that was blown removed, and that's a heavier toroid transformer in it. The 26LQ6 tubes there, grounded grid, not a modulator, nothing special. That's the keying circuit for the relay. That's the relay there. And I guess I'll do this right quick. A lot of people ask, how did the keying circuit work? And I've been through it before, but since I got this open, and since the layout on this one is pretty easy, basically the relay coil, which on this one is the back two wires, back two leads or contacts here on the rear. Well, hard to hold a camera at it and hit it. Okay. One there, and that's the voltage into the relay. One of them is going to be voltage in, which is normally 12-15 volts unless it's a tube type relay keyer, and the tubes, they run on like 100 volts. Most of the relays that are keyed by tubes, but normally if it's a transistor rise, doesn't have a tube keying circuit, it's going to have a little transistor like this, or a little black one that's even smaller. And the voltage again comes to the coil on the back. That'd be your DC in, about 12 volts. And then this other side, when the transistor sniffs the RF coming in, when you key down, it says, oh, we got RF coming in. We're going to put a ground to the other side of this relay, so it grounds it. Anytime you key down when there's RF coming in and it's got DC coming here. Most of standby switches, they turn off the DC coming in, or they might turn it off at another place. They may break a leg in the transistor, but most of them, the DC coming in goes through the standby switch. So when you're in standby, you got no 12 volt DC coming in. Turn the standby switch on, you got 12 volt DC coming in, but it's not a complete circuit because that side is not grounded. Then when you key it down, that transistor puts a ground on the relay and keys it up. I get people asking me, how do you put a foot switch on these? I'd say be very careful with them, because you got to figure out which side has the DC coming in and which one's the ground. On this one, it's kind of obvious, with this going here to the keying relay. But one thing you could do is you can take the ground side, make sure you're on the ground side, and run it through a phono jack for your foot switch, because all this side does when the keying transistor sniffs that RF comes in, it puts a ground on it. So if you run a phono jack straight to here, and then the other side of the wire coming from your foot switch to ground, you know, back to a chassis ground, and when you hit that foot switch, it'll directly ground this contact and key up the relay. So that's how you do that. Basic amp here, high voltage and low voltage power supply board. That there is for the meter, those components there. Basic pi output. Let's see if we can turn her around. Tune and load with your coil in between here. You can see the band switch in the back there. Still, the switch is there, but nothing's connected to it. You can see how dirty and grimy in the buildup on that switch. And so just took all that stuff out, and this amp is just basic 10 meters only, grounded grid, nothing special, no tricky circuits, no bias, no modulator, just a basic 2-tube linear amp, no input tuning on it. So that's the basics on it. So we're gonna turn that on and let it warm up a little bit. And while we're doing that, we're still on our regular mud duck radio. We're on the dummy load, and we got a JB12 in line because the little mud duck radio doesn't kick this 2-tube grounded grid amplifier very hard, so we wanted to show it with the JB12 in line too, and also to piss off the hams a little bit because they don't like modulator type amps, or I call them non-linear amps, because they're designed not to be linear. They're designed to be non-linear and give you a lot of swing on purpose. So anyway, with everything on standby, it's 20 watt scale mud duck radio, keying about 2, and I must be on peak, swinging to almost 10 peak. Audio, well, yeah, 8, 9, 10, whatever. On average, audio. And that's all the little mud duck radio's doing on average. That's why I got the little JB12 in line. We got the JB12 dialed down, so it's only dead keying half a watt, and this is on average. Audio, it's swinging about 10 on a whistle, talking about audio. Only 5 watts on average, but again on peak. Audio, big difference between peak watts and average watts, right? 200 watt scale. Audio, 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 swinging about 30 peak, and that's dialed down. You can dial it up more, but these JB12s are designed for a 4 watt dead key or less. Got the little tuner in the back that you can dial up or down there. 4 watt dead key or less, and what some people do is they don't know the design or capabilities of it. They'll, you know, turn up the dead key for maximum, and you know, little 1 tube 6BQ5 small tube, it'll blow the tube, or eventually probably blow the transformer. And the transformer in it is only, you know, made for 30-40 watts, which is, these things are designed to swing to 30, 40, 50 watts peak. But people dial them up and try to get 50 average out of them, and they'll kill them. You'll see a lot of modulator or non-linear type amps like this with blown power supplies, because people crank them up and kill them real quick. This one's grounded grid, and you don't have any input tuning or dials to vary the watts or anything like that. Just a basic on-off amp with standby SSB, and again, no preamp on this one. So anyway, let's turn the JB12 back off, take it off peak, and turn on the Interceptor 101. Not going to get a lot out of it with you know, 2 watt swinging a 4 going in. Oh, we didn't take it off standby yet. There we go. It's weird how these switches are opposite. You know, on is down, operate is down. I'm usually, you know, most switches you turn up to turn on, but these interceptors, same people who make Firebird, a lot of them, they do it backwards. Don't know why. But anyway, we're back to operate, hopefully, and everything's still tuned up. Okay, we're dead keying 20. Audio. Talking about 30. That's about all with, you know, a couple watts going into it. About 40 watts maybe. I probably could peak it up and get a few more watts out of that, but not going to do that with a camera in one hand and a mic in the other. And on peak watts, just the Mud Duck radio going in. Audio. Talking about 65. Again, though, it would be probably about 100 peak if we had a, you know, 4 watt, you know, swinging a 16 or 20 radio going into it, which would hit them grounded grid tubes a lot better. So anyway, we're gonna put the JB12 on. You know, again, we're only dead keying a couple, swinging to 10 average on the JB12. About 30 peak going into this now. And we want to do average first. So we're dead keying 10 watts. Or if that, audio. Only talking about 40, maybe whistling to 50 on average again. But it's hard to move that meter on average when you got a modulator or non-linear amp in line like that. And last we're going to do peak with the JB12 on. Audio. Big difference between peak and average, right? Audio. It's interesting on peak how it sometimes when you whistle it does less than when you modulate, but peak watts are interesting dynamic. I mean, that's something we're not going to get to here, but anyway, that's it with this Interceptor 101 amplifier. Hello. Guess we're gonna put this on the shelf. Also, by the way, we have another one. No, we don't. We got a Swinger 101 similar to this, and we converted it into a one tube amp, and this one could be two very easily. And I use it for a tube tester. So if anybody wants this, you know, want to keep it as is, or just a couple minor tweaks, and it could use it for a one tuber. And, you know, use it for a tube tester, and, you know, one good tube with a regular radio, you know, driving behind it. You should get about 40 watts out of each tube with the one tube, and use it as a tube tester. This one with the, you know, new toroid transformer and everything redone and recapped and all that, it should last a long time, but ain't the prettiest thing you've ever seen. And that's going to be it for this basic grounded grid. No tricks, no grid leaks, no bias, no screen. Just a basic triode grounded grid amplifier. Bye.